Chapter 5.1, we're looking at nth roots and rational exponents. So the definition of a rational exponent, the nth root of a can be represented as the nth root of a. We can also rewrite that as a raised to the 1 over n. Okay, that's an n. Now we have worked with square roots before, so square root of 9, for example. Square root of 9, there is an index here, or there is a number here, and that is 2. So it's assumed without the number, if there is no number there, that means it is a square root. So what that means is, notice that we have the n here, and it gets rewritten in this form, a to the 1 over n. Therefore, square root of 9 can be rewritten as 9 to the 1/2. Now remember what the square root of 9 is. Square root of 9 is 3. So that stays the same. That doesn't change. So all the answer is 3. Now you can extend the concept of a square root to other types of roots. For example, 2 is a cubed root of 8 because 2 cubed equals 8. So what it's saying is that the cubed root of 8, we can break this down. Cube root of 8 is 2 times 2 times 2. So we can look at the index, or this number here, this 3, as how many do we need in order for it to come out perfectly. So going back to our square root example, remember that the square root of 9, we can break that down to 3 times 3. Now because it's a square root, we only need a pair for it to be perfect. So with the cube root, we need 3. Then we have something called a fourth root, so we'll need 4 things in order for it to come out perfectly. Fifth root, we'll need 5 things to come out perfectly. Okay, so that value here tells us how many we need. So let's define all these pieces. I've talked about the index a little bit, and so let's me be more specific about that. So in general, for an integer n greater than 1, if b to the n equals a, then b is an nth root of a. An nth root of a is written as what we wrote above, nth root of a, where n is what's called the index and of the radical, and a, the number here, is the radicand. It's the number underneath the radical symbol. Okay, so the index, I remember that because n is just like index has an n, so that has an n, so that is how I remember the index. And then notice that the index here is in the denominator of a rational exponent. Rational exponent just means a fractional exponent. So the index is the denominator there. Thinking about the power of a power property, we can extend that to these examples here. You can also write an nth root of a as a power of a. If you assume the power of a power property applies to rational exponents, the following is true. So the power of a power property, that is when we have like x to the third raised to the 5th power. So what do you do with the exponents? We multiply the exponent. So this is x raised to 3 times 5, which is x to the 15. So because we see fractions, it's okay. The property still applies. So this 1/2, that is 1/2. So let me rewrite that. I just want you to know what it looks like because the book has it written in that way. So we're going to take 1/2. And it's raised to the 2, so we're going to multiply it to 2. Now that becomes a raised to the 2 over 2, or a to the first, and normally we just write it just as an a. Okay, we assume that there is a 1 there. So the same is true for here. 1/3 times 3 over 1, that's the 3's cancel, so this is just a. A to the 1/4 times 4 over 1, that is just a again. So here's some core concepts regarding the real nth roots of a. Let n be an integer, n greater than 1, and let a be a real number. So let's first take a look at an even integer. N is an even integer. So for example, we're looking at the square root of 3. So again, there is, if you don't see a number here, there is an imaginary 2 there, or an invisible 2 there. It's a square root of 3. Then we can think about like the fourth root of 16. So I'm looking at the index is even, this number right here inside of that little, like a little valley of the radical. So when a is less than 0, so remember when a is less than 0, what happens with your real nth root? So say for instance, square root of -2. hopefully you remember what that means. Square root of negative 2, that's actually an imaginary. So there is no real nth roots when a is less than 0. So no real nth root. You're not allowed to have a negative inside of a square root. And now we're going to extend that to every even index. There is no real nth root when it's a negative underneath a radical. When a equals 0, so let's take the square root of 0, for example. Square root of 0 is 0, right? You're allowed to do that. Or even the fourth root of 0, that is still 0. So we get one real nth root. Now let's look at when a is greater than 0. So if we are solving for x squared, for example, and we try to solve, we take the square root. So remember when we take the square root of that, x equals plus or minus 3. So we get 2 real nth roots. Okay, just like in this example. So anytime there's an even index, we have to remember to put the plus or minus there because there are 2 real nth roots. Now let's take a look at the odd integer. So if you have an odd n value, so let's say cubed root of negative 8, or let's say fifth root of 1024. So again, we're looking at the number here, that is the index, when the index is odd. If a is less than 0, so if it's odd, so in this case we have negative 8. Now if we try to multiply the same number 3 times, then we can say 8, remember that that's negative 2 times negative 2 times negative 2, right? So that is negative 2 3 times. So my resulting answer here, if I take the cube root and rewrite it, it's negative 2. So I'm allowed to have a negative, and so therefore I have one real nth root. When a equals 0, that's similar to the other one. So cubed root of 0 is still going to be 0. So therefore, we have one real nth root. Now let's take a look at the last example when a is greater than 0. So let's say the cubed root of 27, for example. So I need 3 of them, right? If there's 3 of them, they have to be the same. And so notice that the sign has to be all positive. So in this case, we get one real nth root again. So for our odd, that one we don't have to think about too much. We always get one real nth root. We don't have to worry about a plus or minus or anything like that. If it's negative and it's odd, it's going to stay negative. If it's positive, it still stays positive. Now, even's the one that we have to remember, but hopefully you remember that from your square root properties, that you can't have a negative inside. So it applies for every even root, like with the 2 and the 4. And when a equals 0, that's still the same. It's just 1. And then a greater than 2, there's 2 real nth roots because you have a positive and negative of both.